Alright everybody, welcome back. In this video we're going to look at vector operations. Specifically we're going to look at example 4 from the vector operations lesson. And you see in the box up here some basic ideas as far as how we work with vectors and can perform operations on vectors. In this lesson we're going to talk about addition, subtraction, scalar multiplication, and opposites of vectors. To add two vectors, all we're going to do is take their components and add them. So we'll take their first components and add them together, and that gives us the first component of the sum of the two vectors. And then we'll take their second components and add them together, and that gives us the second component of the vectors. And that's how we add two vectors together. We'll do the same with subtraction, only we will subtract the components. We'll do something similar with scalar multiplication. If we multiply a scalar times a vector, all we're going to do is multiply the components of that vector by the scalar to give us our new vector. And similarly, if we take the opposite of a vector, that's just a special subcase of scalar multiplication. We're taking -1 times that vector and multiplying -1 by both of the components. Alright, so in example 4 here we're going to look at some vector operations and finding component form and magnitude of each of these. So in part A, I want to find the component form of the vector -2u. Well, since u is the vector -3, 4, the vector -2u is going to just be, I'm just going to take -2 and multiply it by each of the components. And so the vector -2u has component form 6, -8. The magnitude of this vector is going to be equal to the square root of 6 squared plus -8 squared. If we calculate that out, that's the square root of 100, or 10. So the magnitude of that vector is 10. Alright, part B. 5v. First we will find the component form. We'll take the vector v and multiply its components by 5. And so the component form of 5v is going to be 10, -25. The magnitude of this vector is going to be equal to the square root of 10 squared plus -25 squared, which is going to be equal to square root of 725, a touch shy of 27. Do I want to simplify this radical? I probably should. Let's see, what can I take out? I've got 5. That's 5 root 29. So that's the magnitude of the vector 5v. Alright. Next, u plus v. In order to find the vector u plus v, I'm just going to add the components of u and the components of v. So the first components, I've got -3 plus 2, gives us -1. And for the second components, I've got 4 and -5. I add those together. So the vector u plus v is the vector -1, -1. The magnitude of this is going to be equal to the square root of -1 squared plus -1 squared, which is just the square root of 2. Alright, next we've got 3u minus 4v. So what we really have is we have the vector 3u, which is -9, 12, minus the vector 4v, which is 8, -20. All I did was multiply the constants times the components, and now I'll add these together, or I'll subtract these rather, and I get -17, 32 to represent this vector. The magnitude is going to be equal to the square root of -17 squared plus 32 squared, which is the square root of 289 plus 1,024, square root of 1313, which I don't think I can reduce. Thinking carefully here. No, I don't think I can reduce that. I think that's fully reduced at root 1313. If you can reduce it, I apologize. It's probably a pretty big factor that we've got to take out. Alright, let's move on to example E. We've got 2u plus 3v. So let's see, 2u is the vector -6, 8. And 3v is the vector 6, -15. So we'll add those two together, and we get the vector 0, -7. And the magnitude of this one is pretty simple. It's the square root of 0 squared plus -7 squared, which is just going to be 7. And then lastly, part F here, we've got -4u, which is the vector 12, -16, minus 2v, which is the vector 4, -10, and when we combine those, we get the vector 8, -6, and the magnitude of that one is the square root of 8 squared plus -6 squared, which is the square root of 100, or 10 as its magnitude. And so that's how we can use various operations with vectors to combine them into other vectors, and how we can find the magnitudes of those vectors. Alright, that's the end of this video and the end of this lesson on vector operations. See you guys next time. Have a great rest of your day.